Hello guys, I'm gonna be doing a video here. This is to help someone else out, help Art out. He was having troubles with his radio. If you've been watching his YouTube videos, he's been working on the Silvertone, Sears Silvertone radio, and it was a basket case when he got it. Been pretty badly torn up. He had completely strip it down, repaint the chassis, and clean it all up. And he's done a real wonderful job on it. Well, he's now at the power up stage, and he's running into some problems, so I thought I'd help him out here. He requested some help from YouTube, from people on YouTube, if anybody knew about, troubleshooting it and finding some problems. Now, he had started out and found that he had some problems, and he repaired those. You can watch the video and check out his his videos on it. Author Hollingsworth. You can check out his channel and watch the videos on this. So anyway, right now we're not really getting much of a signal through. So some of the things that I would do in troubleshooting this, first we need to make sure more or less what we do have working. Is any of the radio working? He can pump a signal in to the antenna, a very strong signal, and get a little bit of sound out of it, very weak sound. We'll get to what is going on there, but my suggestion is, in troubleshooting this, of course some of the standard things you do would be to check all your voltages. The schematic does list voltages for the plates and a lot of the screen grids, and you could check those and make sure that you've got what you're supposed to have. But what I would do is I'd make sure for sure that my audio circuitry is working up to par. So I would inject a signal in using a signal generator. It's got a modulation input output on it, and just pull off a signal off of it. That way you'll just have strictly audio, or if you've got an audio generator you can use that. And I would tap in right here, right at the wiper of the volume control. What this does is we're going to test everything in the audio circuit. If you can plug in a signal here and you're getting good sound, good volume, strong sound, audio out to your speaker, and everything's sounding good, then we know that we're working good enough that we should get a signal through the radio. Now there may be some minor little things, maybe the tone control is not working quite right, or any number of things there. Maybe there is a weak tube. It's not really a big concern at this point. The biggest concern is if you pump a signal in, an audio signal in at that wiper, it feeds from there into the grid and of the first audio amp, which is the 6Q7, which is your dual diode, also your detector also, and it shows that everything is working this way. May not be working perfectly, but it's working. So if you get a good strong audio signal out, you can adjust the modulation level. If you want, you can plug in ahead of the volume control and make sure it's working alright. But what that does is it allows you to know that the audio is working. So you don't have to worry about it at this point. Now from that point I would switch over to my IF frequency, modulated 455 kcs on this particular radio, and I would come in and I would tap in right here. This is the grid cap of the 6U7 IF tube. What it's going to do is it's going to come through this, and if everything's working correctly, it'll feed through the second IF, be detected, feed that audio down through into the volume control, into the first amp, and of course on out to your audio circuitry. If you get a good signal there, then you know at least from this point this way you're in good shape. You can check the condition of this amp by simply pumping a signal in at the plate. If you do that, use like a .001 microfarad cap, just a blocking cap, because there'll be around 240 volts there on that plate, and you don't want to feed that back into your audio generator. So you connect a cap there. You can check the signal level, the strength, how loud it is as it goes through, if you get it through. And then you can come back here and pump it in the grid. It should get louder if that tube is operating. So assume that that's working. Now, there was a comment made about removing the 6K8, pumping a signal in right here, which is the plate of the 6K8, so that you can pump a signal in on the first IF. And you can do that and then adjust the IFs. The thing is, you can do that and that's fine, but if we're going to do that, if we're going to try to make sure the IFs are adjusted and peaked or closely peaked, let's do it here. Take one IF at a time. Pump your signal in here, make sure you're getting it. You can go ahead then, and I do it more by ear. There's a reason for this. I wouldn't get real carried away with it, but you can go ahead and kind of tweak the adjustments and get it peaked out some. You know, if you can louden up that signal, that's fine. And once you've done that, then you can come back here and work with this one. I would leave the 6K8 in. I know the purpose of why he's saying take it out, but I'm going to assume right now that the 6K8 is okay, or relatively okay. So I'd leave him in, and first what I would do, you already tried injecting a signal on the grid, on this lead, down from below the radio. Instead of trying to do it there, pull the grid cap off. That's the grid you're supposed to be injecting the signal in when you was reading on the alignment instructions. Pull that grid cap off, leave it off, try injecting the signal again there. 455 modulated signal into it. If you still don't hear it, okay, the tube may have a problem. If you still don't hear it, then go ahead and go to the plate, feed it in there again with your blocking cap, a .001 microfarad to be fine, and see if you can get a signal. If you get a signal, you can go ahead and tweak this IF a little bit, get it tweaked out to ear so it sounds about the loudest, and then come back and try that grid again. If you can get a signal here and it goes through, but you're not getting a signal here with that grid cap removed, there's a problem with that tube. But let's say you don't get a signal here. Before you actually decide that this is not working, go ahead and pull the tube, get it out of the circuit, and try it again. If you get a signal, but then you plug the tube in, you're not getting a signal, either your wiring's got a problem here, or there's a serious problem with that tube. So, with the grid cap off, you should get a signal through. If you don't, most likely there's a tube problem, especially if with the tube in, you can get a signal at the plate going through. Once you got these two IFs and you know you can get a signal through, then you can start concentrating on what's going on here. Now, assuming the tube is good, assuming at that point it is, let's say that if you do get a signal with the grid cap removed, then put that grid cap back on while you're still injecting a signal out of there. You can reach in there and plug in there. You was checking them before, showing that you was checking to see if you get any sound. So go ahead, keep injecting the signal into it, pop the grid cap back on. If you lose the signal, that means that this grid somehow is not wired right. Now either it is going to ground somewhere, or something's just not right with it. That wire is shorting out your signal, and it shouldn't, but it is. So then you can at least do tracing on it and find out where any mistakes or what's going on there. Despite this, let's say you do get this fixed and you can get a signal through here and everything's working. As far as the oscillator goes, one thing, there's a few things you can do here. One suggestion, that you don't have to break out a soldering iron, you don't have to break out any test equipment or anything. You got a multi-band radio. Now, in this particular radio, it is possible to have every one of the oscillator coils not wired correctly, just in the way the design is. But assuming that's not the case, one thing you can do is the only piece of test equipment you need is just a signal generator to pump in the appropriate signals at the appropriate frequencies into the antenna and go through the different bands. It could be just simply as possible that the only problem you're having is maybe on one or two bands, but the other bands are working fine. So that's one thing you want to check, and it's a quick check you can check real quickly, but just flip through the bands and go to and adjust your signal generator to one of the frequencies that's on that band, and keep doing that. And if you can get a decent signal through on some of the other bands, but say not the broadcast band, then that's where you need to look. Only there. But if you're not getting on anything, then we need to find out why. Another thing you can do when you're checking the oscillator, since you have a scope, is tie in, I believe it's pin 5, let's see, 1, 2, 3, 4, 5, yeah, pin 5, which is the grid of the oscillator. You want to hook it up to your scope while the radio is operating. That way you can see, one, what kind of sine wave it's producing. Is it nice and clean, looks good, or is it really deformed? Two, you can check the frequency and make sure it's correct. And it's simply easy enough to check the frequency. Just remember that it's the difference in frequency that makes your IF. So if you pump in a signal, say you got a signal 1000, in other words, you got it dialed to 1000 on the dial, your IF's 455, then your local oscillator should be running at 1455. So 1455 kilohertz. So, or somewhere in that close range. I mean, if it's 10 kilohertz or something like that off one way or another, you got to play with the dial a little bit to get it there. That's an alignment issue. That is not anything. But as long as you're the right frequencies, the proper frequencies, you're not way off. You're not like 10 megahertz or something in the broadcast band. And as long as it's oscillating, it'll show a sine wave. And the sine wave looks good. You turn the dial, it increases in frequency, decreases in frequency. All that's working. The frequency's darn close. Like I said, it don't have to be exact. That's an alignment issue. But it's in the ballpark. Then your oscillator's working fine. Your problem's somewhere else. If it's not, if it's way high, or not working at all, or really bad shaped, then you could very well have a backwards coil connection here. Now, you asked about how to determine them coils. Well, I kind of went over this, but you've got all the information you need. You made a real good diagrams of your coils. and how they're wound and everything else and where they make contacts at. This particular design on your radio, as you well know, is them coil forms mount directly to the band switches, wafers. So these connections here that come down directly to the band switch on the bottom side of these coils like this, these are those connections that are coming right off the coil form being soldered directly onto that band switch. So all you got to do is look to the other side. Dealing with the broadcast one, it's the windings with the most windings. If it's this winding here, which is the oscillator winding, it's going to be the most winding on that end of that coil, which I think it would be kind of like to the far left if you're looking down on it, or it's furthest away from that particular band switch. It has the most winding. This is your tickler, so it'll have the least number of windings on it. You'll have it's a smaller, less numbered winding. This one actually feeds into the plate, and then they all connect together to go to the ground. So this side here is the side that's going directly to the band switch. This side does not. This side does not. Most likely should not. You pretty well know where this side is because you said this is a C19. You had to move. You had it connected in the wrong place. You can check these connections. Make sure that when you're on broadcast that this end here is making it back through the switch, back up to pin 6. It'd be through this 50 picofarad cap, C12, but it's making it back here. Because that should be connected to here through the switch. But you can check out these connections by simply that reason. When you locate, all you got to do, because like I said, in your drawings, you already located these. You already located these coils. You already got where they make connection on the coil form. If you're concerned, you can flip them. Although it's going to be difficult on this one. My guess is if this coils, there is a problem here. And then we're making an assumption, though I'm going to make an assumption that right here, this connection here, which comes back to C20 here, feeds down, hooks to here, and feeds down and hooks to here to C22 and off and eventually to ground. As long as these are connected the way they should be, which you can check, you know where each one of these caps are, and you can check those. If it turns out that this is turned around, then most likely all of them are off. And the reason for that is being that this thing runs off the coil form, hooks directly smack onto that wafer of the band switch, then it must be off when you soldered it back on. Somehow it got off. How much, I don't know. You'll have to retrace that out to make sure. But if that's the case, most likely none of the bands are working at all. They'll be way off frequency or something, and maybe even some of them completely dead. The oscillator's not working. So that's one thing. I know it's not a perfect answer. I know it's not like, wow, you know, there's a trick. There's no tricks. It is simply tracing things out is what you got to do. And follow the schematic verbatim and trace them out to where everything is making connection. I mean, you can look for stuff like these caps, the band switch, its particular connections, knowing that this end here, or there'd be this end right here, this bottom end, comes down to the band switch in broadcast, makes its way back up to this grid. Again, going through a cap, but that's how it works. You can do a little continuity checking. You'll have to come on this side of the cap because your continuity checker is not going, it's DC, it's not going to go through the cap, but you can check them and check here and make sure. Two things you're going to be making sure of: that you are connected, and two, well, that you are connected. That's really the primary thing. The reason why or not you're connected could be anywhere from it's not hooked up right, or the band switch itself is not making contact. But you can do that. Other than that, again, hook your oscilloscope here, and this will tell you what frequency you're at, and make sure it is correct. Now, you asked a question. You said you tried plugging a signal in here, didn't get no signal, but when you went to the antenna, you got a very weak signal, but it came through. The big, excuse me, the biggest reason for that is this guy right here. This is a 6UF or a 6U7 pentagrid tube, or pinto tube. It's a high gain tube, basically the same tube is being used the IF. They're both high gain, high amplification factor tubes. When you plug that signal into the antenna, this tube amplified it, which is good. That shows that at least some of that's working, because it did what it did. But it built up enough strength that it pushed through here. Even if the oscillator is not working or anything else didn't make any difference, it pushed through, swamped the IFs most likely, and shot a signal through. Weak, but it did shoot it through. But when you came here, all you had was just your 6K8, which these tubes don't amplify a lot. They're not a high amplification factor tube. So assuming that the tube was working right, and the grid and everything's okay here, it would be a lot weaker signal and would most likely not swamp the IFs. And what I mean by swamp the IFs, it's not very good, but when you're looking at an IF, if you just take the graph, you have frequency here, and you can just say voltage here. The IF is going to come along here, and somewhere around here it's going to go up, and it's going to go up real quick and come back down like this under normal circumstances. The thing I want everyone to pay attention to is it's not like this. Filters don't work perfectly. So it's not like it comes along, nothing. We hit the right frequency, boom, boom, and back out. No squares, no anything. There's gentle curves. If you pump a strong enough signal into, you can get a curve that starts appearing, well, depending on where the signal's at, but we'll just draw it like this. That looks more like this. It just swamps it out and everything. Even though the IF's still trying to filter out, it starts losing its ability, it's overdriving, and even though we have a downturn here, which generally we figure where the IF filtering action is, or any filter is at what they call 3 dB down, or at 70%, we're pumping in a strong enough signal that even at that rate, even at that point, it's still plenty enough signal to make it all the way through a radio and still be heard. It does not completely filter it. So that's what I mean by swamping. Excuse the drawing, it's not perfect by any means. So when you pumped in a fairly strong signal into this tube and it amplified it, it was strong enough probably to swamp the IFs, and that's why you was getting the signal out and not here. But there could be a possibility that this grid, and I'm just looking at how it maps out here and seeing if there's a possibility, and it could go to ground through caps and possibly even through a coil, but this grid could be somehow not wired right, and it could be losing the signal, and that's, you know, shorten that signal out somehow. That's something you might want to check. But the way to check that is you pull that grid cap off, inject your signal in, it will work. In fact, a lot of radios tell you to do it that way on a lot of different models or makes of radios. Inject it here, and if you're hearing the signal out here, everything seems to be fine. Then you plug that grid cap back on, you're not hearing it, you've got a problem with that somewhere. So you might want to check that out after you test it. Don't start checking things until you test them. But your initial test on this oscillator too, again, can be done by simply looking at the different bands. Do you have any bands that are working? Any at all? If you got a band working, and it seems to be working correctly, then your problems is not so much how that form mounts onto the wafer switch or the band switch, because if it was off, most likely it'll knock every one of these out and none of them would work. So if it's correct, then the likelihood of you messing up, getting all the wiring on the other sides wrong is probably less. Most likely some of them are working or should be working. So check your other bands and make sure they're working or not working, one or the other. Run the test on this tube by simply feeding the signal in the grid, feed the signal here on the plate. Again, whenever you're doing on the plate, make sure you put a cap in there to block that DC. If you get a signal going through at the plate but not at the grid with the cap removed, then the tube's got a problem. So, you know, you don't want to go through all this and find out you just the tube just went bad on you. So anyway, these are some of the things you can check and look at. I hope this helps. Keep us informed on your progress and stuff. And besides that, I gave you enough to check to at least get you to a next point. Again, work from this way. Make sure your audio is definitely working by injecting an audio signal here. See if you're getting anything. You can also inject here, or you can follow this back, go just on the other side of this capacitor too if you want. If you inject it here, you have to put it through a cap, but you can put it right here on this side of the cap, inject a signal there just to make sure that, just in case this tube is giving you troubles. Either place is fine, and make sure you're getting audio out, a good strong audio out that you should be getting out. You know, it's a judgment call, but if you get, you know, really strong audio out and you can adjust your modulation level or your audio output generator level up and down, and it's going up and down, it sounds strong, it sounds good, then you know pretty well everything's working this way. And then you just start working your way back. When you're going through the IF cans, running at 455 kilocycles, you can tweak them. We're not interested in getting them perfect. When the radio's working, then you can go through the full standard alignment instructions as per the manufacturer, per Sears. But until then, you can do a ballpark. So anyway, I hope this helps you. This has gotten really long. So, and like I said, let us know how you're going, and hopefully you get it working without any problems. Well, thanks again everybody for watching, and I'll see you in the next video.